Hi everybody, I'm Gary King and this is Quantitative Social Science Methods 1. Thanks everybody for joining. I really appreciate especially that you are joining. I hope in the crazy world that we all are all in which basically the entire world has been assigned to the treatment group and they've reserved no one for the control group. I hope you and your family and your friends are all safe and happy and healthy and have found a nice, comfortable place to be. And I hope you're assigned to the control group really soon. In this course, we're going to talk about inference, which is using facts you have to learn about facts you don't have. I am going to start, however, by giving you a broad overview of the field of statistical analysis, and within that, the field of quantitative methods in political science, which is known as political methodology, and within that, this course. So that's what I'm going to talk about today. All right, let's get started. So, what is the field of statistical analysis? Well, it's an old field. You can trace it back to 1662 when a really old book was published. But even at the beginning and all through it, statistics was very closely tied to government and politics. In fact, the word statistics comes from the word state. It's statistics. It was the reformers getting the goods on the state, right? They would collect information in order to try to explain why the leaders should be doing something different than they're actually doing. The leaders, of course, didn't sit alone and ignore the superpower of statistics. They also collected data to hunt for tax revenue from the people. They had to know what the people were producing so that they could then demand tax revenue from them. So statistics got right in the middle of the politics between people and governments. Of course, everybody wants data from government to learn about things that you pretty much couldn't learn otherwise, like collecting data on mortality, which has been collected for 350 years. And there's tons of other things, economic statistics and trade statistics and many, many other things. So statistics is a really old field, but it is also a brand new field with tremendously fast progress happening now that you can be a part of. In the mid-1930s, maybe about the time that your folks were born, or your grandfolks were born, they invented experiments. We didn't actually know how to design an experiment in a way that we could learn in a reliable way about causal inferences. Random assignment was defined then. The advantage of it was discovered then. In the 1950s, the modern theory of inference was born. Inference is using facts you have to learn about facts you don't have. It's not something we really knew in a reliable way much before the 1950s. In your lifetime, we learned modern causal inference in a way that causal effects were defined so that we could evaluate different methods of estimating those causal effects. Of course, humans have been trying to figure out causality for millennia, but it was only in your lifetime that we really figured out a precise definition of what a causal effect is and how to evaluate methods of making inferences about the causal effect. Since you started school, let's say kindergarten, there has been a monumental social change. The change has been described in the media as big data, the march of quantification through the academic, professional, commercial, government, and policy fields. It goes by lots and lots of names, but the reason why it has a lot of names is because it is so important. The number of new methods being developed by all of the people working in these fields is increasing spectacularly fast. The most important of these methods, however, are not actually invented in the field of statistics, in the discipline of statistics, or in departments of statistics. The most important methods, by common assent, including by the statisticians, are, we all know, are invented close to the applications, close to where we need them. When you're focused on the substance of a problem and you really want to find the answer, it may be that there's a method out there to get you what you need, and if there is, go use it, no problem. But if there isn't, then we need to develop it ourselves, and out there in the real world, close to the applications, that's where people innovate. They say, we need this, let's just try it. This includes some of the most important developments, including random assignment and experimental design and survey research and machine learning and Markov chain Monte Carlo experiments, ecological inference. We could go on and on and on. What happens is the discipline of statistics then abstracts the ideas that were developed for a particular application. They prove the formal properties. They generalize these to as many applications as can be. And then they distribute the results back out to that one field that developed it and many others. Statistics is a core, perhaps the core, but a very small core given how far the field has developed. Okay, so what's the subfield of political methodology within statistics? Well, it is political science, the discipline of political science's methodological subfield. It is one of the largest subsections of the American Political Science Association. So to political science, it's an important subfield, but it is also important much more generally, well beyond this particular discipline. It is akin to econometrics within economics, or psychometrics within psychology, or sociological methods within sociology, or biostatistics in public health and medicine, or chemometrics within chemistry. Actually, the list goes on and on. There's probably 100 of these fields. Sabermetrics in the analysis of sports. Yes, actually, that's a serious thing. In fact, graduates of this course have gone on to get offers from professional football and baseball and basketball teams. The union of all of these methodological subfields, when you put them all together, now has some names. And the names are data science or applied statistics or computational social science. There are sometimes others. The connection among these fields is making each one of them much more important. And so the way to learn them, the way to learn any one of them, is to learn one of them and then to look to a broad vista and to see what the connections are in these other fields and to see what methods they might have for their applications that might be useful for your problem. All of this connection, the important advances within each one of these fields and the connections among the fields are part of a massive change in society. In the social sciences, we see that change in terms of the evidence base of the social sciences. The previous period, whatever that was, the last 50 years, has focused on three areas. Surveys, which are random selections of people from unknown geographic locations to which we ask pop quizzes. Okay, so I'm making fun of it, even though surveys are probably the most important methodological innovation in most of the social sciences in the last century. But it's obviously missing some things, right? In addition, there's end-of-period government statistics. There's unemployment rates, there's mortality rates, there's all kinds of other information that governments provide. Some governments provide reasonable information. Other governments, I mean, who knows what kind of data you're getting from these governments. I once tracked down how they measured the prevalence of AIDS in Africa. Because in a lot of Africa, there's no vital registration system. There's no death certificates. People just sort of, sometimes in some places, they just sort of go off to the bush and are never heard from again, and that's it. So how are you supposed to figure out not only whether they died, but what they died of? Right. So I tracked this down basically to a guy in the World Health Organization and named Alan. And Alan would take the numbers from all the countries and he'd look at them and he'd say, this can't be right. This isn't right. And he'd cross it out and he'd write another number. And those were the numbers that researchers were using. And you know what? Alan was really good. So he was the right guy. You wanted the results from Alan rather than from the country. But in any event, the second number is the second source of the evidence base of the social sciences in the past half century was end of period government statistics from not so reputable governments in some cases. And third are one-off studies of people, places, or events that we as researchers often created. So those are very important sources of information, but going forward, it's different. Right now, it's different. What you're likely to do going forward is different. There are numerous new types of data. huge quantities of big data. Previously, if somebody wanted to do a quantitative dissertation in the social sciences, they would download an existing data set from some institution like the Inter-University Consortium for Political and Social Research. They'd download it and then they'd write a quantitative dissertation. If you were in American politics and political science, it would probably be the American National Election Study, which is a survey of the public during election times. Now, what happens is most dissertations, not quantitative dissertations, but dissertations, collect data that's unique to the dissertation. Same thing with senior theses, same thing with plenty of other projects. It turns out now to be possible to contribute knowledge, not only knowledge extracted from existing data sets, but knowledge extracted from the world. Many of these dissertations, many of the folks working on this stuff learn and develop new methods to suit the particular problems. It is possible now to go home over the weekend and scrape with Python a tremendous amount of information from lots and lots of different sources. Those types of information, those types of data, in many cases, no prior methods exist for those. So we're going to need to know not only how to use methods, but how to find methods that exist out there that might be appropriate for our problem. But where necessary, we need to be able to develop the methods a little further so that they can solve our substantive problem, not for the method's sake, but for substantive sake. Okay. Why do this in political science? Why is political science the place that you should get your methods training? I mean, you could go to statistics, and that would be a great thing to do, and you would be doing the math, that core, that small core, but not where the action is in some sense. You could go to econometrics, you could go to psychometrics, and all those would be great places. But political science is an unusually special place to do this. It is an amazingly diverse discipline. And, in some sense, the discipline of political science has like everything except for discipline. It is the crossroads of many, many other fields. In my own department, the people in my own department have experience in and often degrees in, and they often publish in, and they read articles in journals from political science, law, economics, sociology, anthropology, sometimes biology, statistics, data science, econometrics, some of these different subfields, public health, medicine, education, lots and public policy, lots and lots of other fields. That's the unique thing about political science. If you take two graduate students and let's say in economics, which is a terrifically valuable and informative field, and you send them to different graduate programs halfway across the world, the first year, they're likely to take the same courses. If you take two graduate students and send them to any one program in political science, they're likely to take different courses. Political science is an incredibly diverse field. And because of that, because it's such a diverse field, you see an enormous variety of methodological problems, an enormous variety of data sets, an enormous variety of substantive questions that are asked. And because of all that, it is a terrific place to study methodology because you get the experience of not only what's going on in political science, but what's going on in many, many other fields. Okay, so what's this course in political methodology about? Well, it's about understanding statistical inference, it's about making novel contributions to a statistical literature, and it's about learning how to choose topics for research, solve hard problems by changing the question, and identifying the big idea. Let me describe each of these. The first two we know more about. The third one I'm just trying to figure out. So understanding statistical inference. Inference, as I said, is using facts you have to learn about facts you don't have, right? That's basically what we do in everyday life all the time, and it is certainly what we do in science, and it is what research methods is about. It is what graduate school is about. It is what academia is about, at least the empirical pieces of academia. Understanding statistical inference involves understanding statistical theory, and not just any statistical theory, but the theory that underlies the specific methods that you're interested in. That's what we really have to understand. It's not just the method. We have to understand it deep enough so that other people can use it if we explain it to them, and so that we can use it in a way that we're sufficiently comfortable that we're not focusing on the methods, we're focusing on the substance. You should feel comfortable using these methods in your own work so that you know you're not going to be criticized for something you didn't pay attention to. You know that you're going to be able to learn and extract as much information about your substantive questions from the data as possible. You should be able to, with this knowledge that I hope we can give you, you should be able to learn, implement, apply, interpret, explain new methods invented not only in class, but after class. So that's really important because most of the new methods in the world a year from now will have been developed after class. We need to give you the underlying theory so that you understand the methods that exist now well enough and where they came from so that when new methods appear, 2 weeks after class is over, you can go read the article, understand it, implement it, interpret it, and use it in your research. Okay. We also want to give you the practical tools of research, the theory, the applications, simulation, programming. I don't really care what it is, how high a theory we're not going to apply any particular rules about what it is we're willing to teach and learn and focus on in this course, other than is it useful for you in your research? That's all. If it is not useful, we're not going to do it. If it is useful, we are going to do it. It doesn't matter whether you might regard it as plumbing or you might regard it as high theory. If it's useful, we're going to do it. Okay, so second is we want to make novel contributions to a scholarly literature. Now that sounds wacky, okay? It is the point of being in graduate school, right? In graduate school, you really only need to learn one thing. I tell my students they come to Harvard and they're wondering what it is they have to do here. And I say you have to learn one thing. If your goal is to become a good researcher, you have to learn how to do research. If your goal is to become a good teacher, it turns out that teaching and research are best when they're together. And to do that, you have to become a good researcher. You have to learn how to do research. You want to go work in industry, learn how to do research. Research involves making novel contributions to a scholarly literature. It's not something you've done before. It's not something you know how to do. It is something that you and we will figure out together in this class. It sounds hard, but almost everybody in this class gets there. Graduate students, undergraduates, everybody. Revised versions of class papers in this class from entering students who are basically you shifted back a year or two, or 10, have turned into many, many, many published articles and books and senior theses and dissertations and blog posts and conference presentations and job talks and won lots and lots of awards. There's one particular quite prominent award that people from this class won 4 years in a row. So it sounds scary. It sounds like I don't really want to be evaluated by that standard because I don't know anything about it. And that's true. You don't know anything about it. We don't expect you to know anything about it now, but we know that you will figure it out by the time class is over. Okay. The third one is how to choose a topic for research, how to solve hard problems. Nobody knows how to do this, but it is really important. And the point that I would make here is that the biggest factor in impacting the success of any project is really the question you ask. The biggest factor impacting your success on a test where you're asked what's the answer to this question is the question, right? From nursery school until today, you've learned, it's been driven into you that you may not question the question. The questions are fixed, immutable. They are given to you by God or the professor, or the teacher, right? They're just given. And you may not touch them. That's the test. You have to try to answer the test. Today, when you're in graduate school, or if you're an undergraduate listening to this, I'm going to treat you like a graduate student, you can change the question. You can choose the question. You can go in the direction that you want to go. And that can be incredibly valuable. In fact, taking the same research and just recasting it in a different way can make it more interesting to your audience, can make it easier to solve, In other words, you can avoid important methodological problems by reframing the question and going after something that may still be incredibly important, maybe even more important, but doesn't have the methodological problems that you've seen previously. Okay, so who takes this course? Well, it's taken in three different ways, really 4 different ways. The first is you can just watch the lectures. Secondly is at Harvard, there's Gov 2001. Most Gov graduate students doing empirical work take this course. Many graduate students from other departments at Harvard and schools take the course. Second, there's Gov 1002, note the symmetry, 2001, 1002, isn't that great? Undergrads take this course, and we have special things designed for them. And then third, we have Stat E200, which means it's through the Harvard Extension School. And non-Harvard students take it, visitors, faculty, graduate students from other universities, all through the Harvard Extension School. Note the word online here, as if remember back in the old days when that was different than actually in person. Anyway, some of the best experiences here involve getting to know people from some of these other fields. So it's really useful that you get to understand that there's different kinds of people seeking different kinds of information for different substantive purposes, and they're interested in different methods, and they're in different types of programs, and getting to know them, perhaps writing a paper with them, perhaps working on problem sets with them is really useful. It's some of the best things that come out of this course. Okay. What are the requirements? What do you actually have to do? Well, if you want it to be a good experience, you do the following. First of all is you engage in the collective experience we've designed. I'll explain. Second, there's weekly assignments. And third, there's one publishable co-authored paper, which has got to sound scary. And if it doesn't, then you don't really know what we mean. Don't worry, it won't be so scary. Okay, so engage in the collective experience. There'll be lots of assignments, of course, but they'll be carefully choreographed dances with other people in the class. They'll see what you do, you'll see what they do for certain types of things. They'll rely upon you, you'll rely upon them. So you really want to make sure that you turn things in when they're due. The whole class depends upon you. So come to class, meet the deadlines, watch the Gardon lectures, do the reading, support your classmates. We know from lots of prior classes and from serious educational research on prior classes that this is what's going to get you to be in the best situation to use the appropriate methods in your research and perhaps to develop the methods for your research. We all learn better collectively. Like the evidence shows that social connections motivate learning. Also, the content motivates learning. The only thing that doesn't really motivate learning in a particularly good way is grades. So I don't really care about the grades. I care that you learn from the class, and the evidence shows the more you put in, the more you get out. The more you put in, the more you get out. Okay, weekly assignments. Well, we're going to do readings and lectures in an app called Perusal. So the word perusal means to read, and I noticed that my students in class, when I would say, hey, do the reading, maybe 20 or 30% of the students did the reading. Then I looked into the education research, and the education research showed pretty much any instructor anywhere around the world, if they say, do the reading, and unless there's a quiz or some other kind of penalty, 20 to 30% of the students do the reading. So my colleagues and I developed this technology, and we added an extra L to the word perusal, which means to read. Now it's peruse all, so read all of it. And it enables social connections among all of us outside of class for readings. And for this year, we've added lectures, so you can engage with the readings and engage with the lectures. So the idea is that reading for millennia has been a solitary experience. If you want a collective experience, you come into class, right, and you participate in the classroom experience. That, by the way, was never the greatest experience because sitting and watching a lecture is not always the most motivating thing when you're sitting there in class. If you have a question as a lecturer, we think we get the most out of it. We think it's a really great thing. We lecture as I'm sure you have or will. We ask questions. We get questions. We can pitch what we're saying at a different level. It's really terrific. But if you're in the class and you have a question, like, you can ask a question. It's a really good thing to ask a question. But it's hard to actually ask a question, because most questions that we have is, hey, could you say that again? I wasn't really paying any attention. And you can't stop the whole class and stop all your fellow students from learning to do that. So maybe it's actually useful that there's a rewind button on this lecture. But reading, so in class it should be the collective experience, but reading has always been a solitary experience. Perusal makes the reading an engaging collective experience. So you can annotate the readings, we can respond to each other, Facebook style in threads. You know, so somebody says, I don't understand this. Another person in the middle of the night, rather than waiting for office hours, can say, I think it's this. Somebody else can say, no, I think it's that. If your fellow student gets it wrong and you help them get to the right answer, you not only will get to the right answer, but evidence shows that you're more likely to remember it forever. So learning in the context of social engagement is way better. So this year, as I said, we put video, including this video, into Perusal so that you can also annotate the timeline and ask questions and receive some response. When you annotate, you help others, okay? So really do it. You know, read slowly, engage with the material. It really matters. It matters to everyone. It matters to me also, by the way, because what you're engaged with, what you're confused about, what you have questions about, what you find interesting, I want to know when we come into class. Because once we have that engagement and we have a record of it, Perusal will summarize for me what that discussion was. And then when we come into class, we can have a discussion about the things that you actually care about or would like to know more. So please annotate the readings and annotate the lectures. It doesn't have to be, you know, every sentence, but if you're confused about something, if you're interested in something, if you're engaged with something, if you'd like to hear more about something, just put an annotation there, right? Just ask a question, you know, and if a fellow student asks something, please respond to them. This matters. Okay, our research shows that it matters. Our research shows that students who use Perusal actually do better in class. So they do better, like at the end of the year grades. What else? Well, there's problem sets, there's assessment questions, and the idea here is we will ask you to take the problem sets home, give it a try yourself, and then cheating's okay. Okay, here's how cheating works. Okay, find a group of 3 or 4 people, work with them. You know, you will have tried it at first yourself, but I don't expect that you necessarily will have gotten the right answer or even understood all the questions. In the interactions among your fellow students, you talk to them, you try the problem, you know, you'll have different strengths, you'll figure it out, okay? Or at least you'll get closer. That's a really important process. Then, when you have what you think is the right set of answers and the right set of explanations, take what you learned and just go home and write it up yourself. If everybody in a group, a study group, hands in exactly the same assignments, I'm canceling all your credit cards. Okay, so don't do that. Okay, that's a joke, by the way. But aside from that, it's perfectly fine to work over the answers together. Okay. If you have any questions about class or about the problems, about the problem set in particular, I want you to annotate the copy of the problem set that's in Perusal, because then it's fair that everybody would be able to see the answer that my teaching fellows or I would see. In here, we're going to have peer grading, as you'll see, and peer instruction. The point of peer grading is not to grade each other. The point of peer grading is to help each other. And you'll be graded by how much you help each other. Right? So for the most part, it's just helping. It's not grading. If you've ever tried to explain something to someone else, you know that they might have learned something, but you definitely did. Right? And I say teaching teaches the teacher. So what we want to do in this class is turn you into teachers. I'm giving you a pitch on the basis of my research. I've worked hard on figuring out how it is that students can learn better, faster, and more securely and remember it for a long time. And we're going to be using that in this class. Happy to talk about it if anybody has any questions. Okay, third, one publishable co-authored paper. Okay, wow, okay. We're going to have a draft submission process. We're going to have a replication exercise. All of these will help a lot and make it much easier. And make it so you're not doing it by yourself. To begin with, it's co-authored, but there's much more to it than that because we're going to be working on it together. I came up with this assignment in this class over quite a number of years. I worked on it and tuned it, and then I saw what the outcome was, because my outcome was publishable papers and published papers in professional journals. That was my outcome. And I tuned the assignment every year until I got a good number of published papers. And so I keep tuning it every year. And so we will give you this assignment, and we will we will continue to experiment on you during this. It actually works. So you won't be alone. You'll work with each other and with us. And it really matters that you do it in sync with everyone else. And you are likely to come out of this class with a paper that, if you put in some more work, maybe over January or over the summer, it's likely to be a publishable paper. Not every time. Sometimes the world doesn't comply with our ideas, but lots and lots and lots of times. I would say most students, most of the time. Okay. There's the papers are co-authored, as I mentioned. There's also a peer grading exercise and peer instruction as part of this as well. Okay. So course information, where do you get all the info on this course? Right there, that website. So write it down, j.mp/G2001. Go ahead, I'll wait. Go ahead, go get a pen, write it down, j.mp/G2001. I guess you could just come back to the video and try to find this spot, but j.mp/G2001. Okay. I want you to find a study group of maybe 3 to 6 people that you can go over the problem sets with. That's the best. That tends to be the best experience. It's a little weird if you have to do it all by Zoom, but you know what? Harvard has a gigantic campus, and this has happened in previous years, even without a pandemic, that people do problem sets sometimes over video conferencing. And then, separately from your study group, although perhaps overlapping with your study group, I want you to have a co-author group. So I want you to find 1 or 2 other people, so the co-author group has 2 or 3 people in it. That's about the right number, okay? It's possible that you could have more. 1 is not acceptable. The assignment is a co-authored group. You want to pick somebody not who's willing to work on your project necessarily, right? And you're not necessarily going to work on their project, but it might be that one of you actually does choose the project. That's okay. Or it might be that you go after something completely different. You want to just find people that you can work with. That's all. Okay, and you all need to be cooperative, and you're getting along. We all learned how to get along with each other in kindergarten, or at least we gave it a try. We have to figure that out here. Okay. All right, so when are my office hours? People always ask this question, and since I started teaching, I've never had office hours. The big secret is office hours prevent visits at times other than office hours. Okay, so that's the really weird thing. Come when you like. If you can't find me or I'm in a meeting, come back or talk to my assistant. It says here in the office next to me, that's when I actually had an office that we could actually go to, or send a chat by perusal. I think this year we're going to experiment with another teaching idea, which is we're going to post anybody that wants to meet with me or with the TFs. We're going to post who it is and when it is, and we're going to have 2 or 3 other slots, and hope that anybody who has a similar kinds of question, because we'll put the name and also roughly what it's about, and we'll hope that people we will want you to sign up in small groups, not large groups, but small groups. Obviously, if you have a personal question about something that just involves you, then sign up, and I'm perfectly happy to talk to you anytime. Okay. Focus like I will in this class, on learning, not grades, okay? All the evidence shows that if you focus on grades, maybe you'll get an okay grade, but you're not going to learn anywhere near as much. And by the way, if you're a graduate student, no one cares what your grades are anymore. Nobody cares. I totally understand that you're genetically incapable of hearing that sentence, but it is utterly true. Now, those of you who are undergraduates, I know you're saying, well, we're not graduate students, we're worried about grades. Yeah, but have you seen the average grades, at least at Harvard? Okay, I think the median is an A, okay? So really, just let's not worry about it. Let's focus on the material. And remember, the more you put in, the more you get out. And then we won't have to worry about the grades. We'll worry about learning something in this class that you're going to remember 10 or 20 years from now. All right, so what's the strategy? Well, we could teach you the latest and greatest methods, but when you graduate, those methods are going to be pretty old. We could instead teach you all the methods that might prove useful to you, but if we did that when you graduate, you would be really old because it would take forever, basically. Instead, we're going to try to teach you the fundamentals, the things that will stick, the things that will generate the foundations of other methods. The underlying theory of inference, using facts you have to learn about facts you don't have, from which statistical models are developed. That should make you sufficiently comfortable to apply a new method or to learn new methods that are invented after class that I've never even told you about. All right, another question is, well, is this like a math class or is this an applied class? Okay, it's not really either one. Here's how it works. There's often a balance in statistics classes that have to be between proof and concepts and intuition. But the usual balance is between, first, on the one end of the continuum is what's often called baby stats. And that's actually what we all call it. And it's basically dumbed down proofs or vague intuition, and pretty much you just name a whole bunch of stuff, and when you name things, that tends to make us feel comfortable with things, but that's not really particularly useful. I mean, it may be useful as a first step. You may have taken a course like that. I took a course like that, but it's just a start. At the other end of the continuum is mathematical statistics, rigorous mathematical proofs with essentially no data experience. I'm not going to do either one of those. I'm going to do what we might call practical statistics. Math as deep as necessary when it's needed. Concepts always as deep as we can, so we can completely understand what we're doing, and deep intuition. So we're not going to shy away from the math, but I'm not going to be showing you math all the time. If somebody else proves something and the proof isn't going to give us deep intuition for the substance, fine. We'll just take their result. My guess is very few of you know how to prove that the SQRT on your calculator or in R actually works anymore. That's fine. It's okay. You can trust them. If you ever need to really figure it out, I have confidence you could figure it out. But there's some things that we can build on others. However, if it is useful for us to understand the substance or advance the substance, that's what we're going to focus on, and as deep and as detailed as necessary. So the ultimate goal is to learn how to do empirical research in depth. The procedure that we're going to follow will traverse the theoretical foundations from practical application to how-to computations. All the way, right? So there'll be theory on one side, and there'll be practical, how-to things on the other, and we're always going to go the whole range. We're going to make sure that you understand enough about the theory and that you can use it in your work. All right, give the background for this class. Well, here's what you need. Some data analysis. Typically, people come to this class. This is a first class in quantitative methods taught in graduate school. People will typically come to this class with one course as an undergraduate, some math background maybe, but one statistics course. In this statistics course or in your prior preparation, we would hope that you would have some data analysis experience, using some statistical procedure to get a feel for data. Second is R. We're going to rely upon the the statistical computing program R. And if you don't have it, if you have experience in Stata or something else, that's okay. You can learn R, but we're going to want you to do that. So we'll show you how to do that. You can go to our website. Remember, j.mp/G 2001. You can go to that website and you'll see ways of catching up and filling in, backfilling information, or talk to our TFs or to me and we'll help you. And third, the third piece of the foundations that we're going to use is some probability theory, particularly some background in distributions, normal distribution, Bernoulli distribution. We will go over them in class, but some familiarity tends to help. So having those three things is pretty much the background for this class. One undergraduate class typically offered in political science programs is basically our standard that we're going to try to meet. Okay, a couple of slides. One is the big picture. So the big picture is inference. All right, so what is inference again? Inference is impossible. It's impossible, right? Because it's using facts you have to learn about facts you don't have, and the facts you don't have may have nothing to do with the facts you do have. So it's impossible, but as it says here, just because it's impossible doesn't mean we shouldn't do it or try it or go for it anyway, because we do need to understand that the facts we don't have, and what else could we use aside from the facts we do have, right? So that's what we're gonna focus on. All right, so now let me give you the textbook view of how this is done, not because anybody follows the textbook, I promise you they don't, but because we're going to list all the parts. Because all these parts I'm going to show you, you're going to see them, you're going to learn them, you're going to become familiar with them, and you're going to be able to use them in your research. And then after I give you a list of the textbook components, in the textbook order that is, you may do it in another order, you're likely to do it in another order, no problem. But after we get to the end, on the same slide, I'm going to give you ways of dealing with problems in the original list and ways of avoiding problems in the original list and other topics that we're going to have to go after to deal with the normal textbook presentation. Okay, so first of all, by the textbook way things go is we're going to choose a substantive question of interest. Now, this is one of the reasons why the textbook seems sort of nutty. Where are you supposed to get that from without having any experience or anything? You just sort of get it from God somehow. But in any event, you may come with some prior knowledge, I would think. So you come and you have a substantive question of interest. Then we're going to formalize that qualitative question into a precise quantity of interest. Instead of, well, is mortality high? No, we're going to define what we mean by mortality rate. We're going to define the population. We're going to define the measure. We're going to figure out not yet how to measure it because this is just the quantity of interest, right? We're going to define it theoretically incompletely, but given the question. Then we're going to decide what data to collect that would best get at that quantity of interest, given the quantity of interest and given the qualitative question. We're going to assume some class of statistical models, a class of statistical models, like maybe all linear models, given the data, the quantity of interest, and the question. We're then going to use an estimator, which is a function of the data, in order to choose the best model in the class, right? In other words, from the class of all possible linear models, we're going to choose just this line, right, given all the above. And then we're going to figure out how to present results in a way that is compelling to the audience, to our audience, whoever that is. And by the way, the audience when you write this paper is not me. The audience when you write this paper is the amorphous, anonymous audience out there for the journal you're going to write for. And we're going to figure out what journal you're going to write for. When you do that, remember, you have to get past the reviewers. So they're also your audience. And reviewers are anonymous. And anonymous human beings are really nasty people. They don't give you the benefit of the doubt. Okay? So we're going to have to figure out how to do that, right? How to write for them. And remember, you don't get to know who they are. So we'll have to figure that out. You're not going to ever, I hope, take the results of what comes spewing out of a computer program for some statistical procedure and just stick those in your paper. because what we're going to do is not let the computer program decide how we present things. Instead, we are going to change the statistical results so that they are conveyed in a way that is best communicated to our audience and best communicates our most compelling results. Okay. The quantity of interest should be interpretable by anybody. They should come with uncertainty estimates, confidence intervals, standard errors, etc. All right, some open questions that we're going to answer about this textbook presentation include the following. We're going to focus on better ways of presenting results. We're going to deal with model dependence, which is, suppose you run a model, you get results, but you made a whole bunch of decisions when you were specifying that model. You know, like maybe you didn't know which measure of a particular variable to include, and so you put one in, or maybe you tried it both ways. Or you dealt with missing data in a different way, or you dealt with measurement error in a different way, or you didn't know whether to go back to World War II or World War I, and suppose the answers that you get, the statistical answers that you get, change in big ways as a function of all these decisions, and suppose the decisions are things that you can't really defend in any compelling way. What do you do in that case? Okay. In that case, you have model dependence, and we're going to have to deal with that. There are ways of defining very precisely what model dependence is, evaluating how much you have, and then correcting for it. There's also model dependence not only of which linear model, but of the whole class of models. Maybe you chose the wrong class. We'll have to deal with that as well. In addition, there's data problems, right? All kinds of data problems, like the ones I just mentioned, and maybe some of them are miscoded, and maybe that guy at the World Health Organization did it the wrong way, and all kinds of things. We'll have to deal with every one of those. We'll also pick more interesting quantities of interest than the ones that are natural. We're going to pick them based upon what would be most compelling to your audience. And we'll show how to pick different ones. And of course, we'll be able to pick more impactful, substantive questions to avoid the problems that we went after in the first place. Okay, let me give you one more slide just to presage what's coming next, because what's coming next is statistical modeling. Okay, so let me just ask you, what is this? Okay, yes, this is silly. Okay, but what is this? And you ask yourself, what is this? So instantly, of course, I think you would probably know this is a person. Okay, but if you thought to yourself, that's a person, or he's conveying what a person is, of course, now you know what a model is, because actually this is not a person. Most people are somewhat more three-dimensional than this little guy. Okay, this is an abstraction. A model is an abstraction. You might ask the question, is this model true or false? And you sort of think about that. Is the model true or false? Well, I mean, he's got 5 fingers on each hand, so maybe it's true. But actually, it leaves out a whole bunch of stuff, right? It is a crazy question, right? I mean, think about this, like, am I a model of a person, right? Well, I'm not saying I'm a model person. I'm just saying, am I a model of a person? Well, I'm more realistic than that guy, okay? But if I'm more realistic than that guy, I guess he's over there, right? Or maybe he's over there. Let's see. No, I think he's over there. Anyway, wherever he is, that guy is not realistic. But you think maybe I'm realistic because I can walk and talk and give speeches to my webcam, right? But on the other hand, I'm completely and utterly different than you. So maybe if I'm a reasonable model, a realistic model, maybe you're not. Maybe you're not human. Like, what does that mean, right? So how about this question? Are models realistic or not? Am I realistic enough? Like, there isn't any other human in the world, so far as I know, that's exactly the same as me or the same as you, right? So maybe this is also a dumb question as well. It's okay to ask the question, is the model realistic with respect to the features we care about? But it's not reasonable or interesting to ask the question, is it realistic overall? Okay, so the question we are going to ask, the question that is relevant, the question that will always be central when we're choosing a model is, are models useful? Is this model useful for your research? Useful, not realistic, not true, not correct, or anything like that. Okay, it's always a good question. I'll give you an example. So for a little kid, suppose you want to know you want to convey to the little kid what an airplane looks like. So you could have an airplane, you could have a propeller, and you could have a fuselage, and you have the wings, and you have a little tail, right? And maybe even you have little holes, and you look in the holes of the windows, and you can see maybe little people in there and stuff like that. That's pretty good to convey to a kid. Suppose instead we came up with the following model. On the vertical axis is amount of dirt on airplane, and the horizontal axis is time. Okay, so the amount of dirt on airplane, let's say, goes up and down over time, right? You know, a lot of people get on the plane, they leave a lot of stuff behind, right? And so maybe the amount of dirt goes up when people go on the plane. They get off the plane, the dirt doesn't go back down to its original level. Would that be useful to convey to a little kid what a model is? No, not very useful, right? But is it useful? Yeah, actually, for the airlines, it's incredibly useful. It's hard to imagine, it's hard to imagine that it is useful, but it is really useful. Why is that? Well, because flying an airplane is very expensive. Getting it up into the air is very expensive. Jet fuel is very expensive. And if you're spending expensive jet fuel to fly up in the air, old magazines and just dirt, like you're wasting your money. So have you ever noticed when you get off a plane, a crew follows you onto the plane and they pick up all of the stuff, all the garbage, not because they want the next group to be in luxury, but because it's expensive for them. And they come and they vacuum, and actually vacuuming gets up enough dirt so that they save a lot of money. So the model is useful if it's useful for your particular purpose. It's not useful in general. It's not real. It doesn't matter whether it's realistic. It doesn't matter whether it's true or false. It matters whether it's useful for your particular purpose. So we will change the model depending upon what your question is. Okay, so that's what we focused on here. We're then going to go after statistical models in more depth next time, and a whole range of other really cool topics that I really look forward to talking to you about. So thanks for listening, and I hope to see you in class. Take care.